Alright, hey guys, welcome to this session by Great Learning. My name is Anirudh Rao, and in this session, we are going to take a look at and understand everything that you guys need to know while you're getting started to understand statistics for the beautiful world of data science. Now, ladies and gentlemen, welcome to this session from wherever it is you're tuning in from. It's a beautiful evening here in Bengaluru, and I hope you guys are as excited as me to get started with statistics for data science, right? Now, ladies and gentlemen, before we actually go ahead and begin with this session, can you all quickly head to the chat box and type in a quick yes or a no? Type in a quick yes in the chat box and give me a confirmation if you can hear me fine, if you can see my screen fine, and post your confirmation. We can actually go on to begin with the session, right, guys? Now, while you guys actually go on to give me a confirmation, I want to tell you that as always, I'm monitoring all of your comments here in my mobile phone itself. So any questions that you might ask, any questions that you might have, please head to the comment section and just put it down there. I'll make sure to answer. I'm going to pick up each and every one of your questions and I'm going to answer them. Right? Alright, so a lot of people are giving me confirmation. Prasad says yes, Praneet says yes, Emika, Enya, Gaurav, all of you guys say yes. So guys, welcome to this session. Without further ado, I think we can get started with the agenda of this particular session. Now, ladies and gentlemen, whenever the talk is about statistics and whenever the talk is about data science, it is always a value addition that you start from scratch. If you're a person who's getting into the world of data science and you want to strengthen your concepts of mathematics, strengthen your concepts of statistics, it always helps to revisit it, take it in a very structured and an easy manner to learn. Right now, ladies and gentlemen, when you take a look at the agenda, we're going to start this out by, of course, having a very quick introduction to data science, because I understand that some of you may or may not have had first-hand experience working with data science. So we're going to take a look at that. And once you understand what data science is, where it is used, why is it so popular in today's world, you'll be very curious to know, hey, so how does the entire life cycle of data science work, and where do we see statistics fit there? Once you are clear with that, we can take a look at the various types of statistical analysis we can go on to perform. What are some of the most important concepts that govern the world of statistics, especially for data science? We're going to take a look at all of that as well. And we are going to be taking a look at a wonderful demo where I'm going to be guiding you about all these things that we're going to learn theoretically. We're going to be quickly implementing them in Python, and all of these concepts that I'll be trying to explain, I'll be giving you really simple examples as you guys will understand. I promise you that you're going to have a ton of fun, right? Now guys, before we jump right in, do take a second to hit that subscribe button, and of course, if you like whatever it is that you're watching, do take a second to like the video as well. Now, whenever you guys subscribe and whenever you guys hit the bell icon, as soon as we put out a video, you guys will be the first ones to get notified of the same, right? Okay, on that note, fantastic. Gaurav says, please also tell from perspective of freshers. Yes, Gaurav, definitely. As I already told you, I understand that some of you all might have not used these concepts, hence that's the reason I'm going to be covering it, and I'm going to be trying to cover it in as easy as possible in easy bite-sized chunks. Now, coming to data science, ladies and gentlemen, what is data science? When we take a look at understanding what the process of data science is, or what the entire world of data science is, it is nothing but taking raw data and converting it into useful information later. Now, you might be a person who says, hey, data, isn't it already useful? Yes, to a certain extent, data can be useful, but as a raw entity, right? So probably you picked up data from your competitors, you picked up data from Twitter, or your client sent you some data. You have to understand that there can be certain misses, and especially if you're using the concepts of algorithms, machine learning, deep learning, and all of that, even though you feel that your computer is probably the most fastest processing machine that you might have, which is true, but at the end of the day, it can only figure out zeros and ones. So to give it intelligence, you have to teach it and train it from scratch. And if you're doing it using incorrect data, that'll just be a tumble down effect, right? So it's very important to make sure that you guys are using accurate data. It can be super accurate, but still at the same, it's just like food, right? I'm sure that all of you all have your favorite foods. Some of of it might be raw, some of it might be processed, putting it in oil and all of that. So this happens for data as well. So taking it from one form, converting it to another useful form, which at the end of the day can help not only predict what went wrong in the past, also data science gives you this wonderful ability to predict what will happen in the future as well, right? So that, in my opinion, is a very well-rounded definition of what data science is. Now, when you look at data science, to be very honest with you all, I am sure you already know this. This is considered to be one of the most popular domains in the world of information technology. A data scientist's role, pardon me for my informal language, but it is considered as the hottest job in the market right now. And when you take a look at the most paid careers that are out there, a data science role, be it data analytics, be it data engineering, be it business intelligence, or any of these things which are again inside the world of data science, the highest paying jobs in the entire 21st century. Which domain do you think it lies in? It lies in data science, right? So why is it so popular? Why is the entire world going gaga over data science? To be honest with you, we are generating a lot of data every single day, right? So by the time you heard the snap of my finger, each and every one of us, I see that there are 60 people who tuned in to this session right now. All of our hard disks would be full by the time you heard the click of the of my fingers, right? You might say I have 2 terabytes, I have 4 terabytes hard disk. Regardless, we are generating terabytes worth of data every time we blink our eyes. That is how much of data we're generating in today's world. So there was a time, probably 20 years back, if you said, hey, I'm going to predict tomorrow's weather, there's a very good chance that people might have laughed at you. But today, if you say, hey, I have data for the last 20 years worth of weather and I can sit and predict what the weather is like tomorrow, everyone will be very interested in that, right? In your phone right now, you can open up the Google Assistant or Siri if you guys are using Apple devices, and just say, hey, what is the weather like tomorrow? How do you think Siri knows what the weather is like tomorrow? Tomorrow isn't even here yet, right? To do that, it needs a large amount of data. And once we have a large amount of data, we need a structured process to handle all of this and eventually ensure that it will help us right from the start to the end, right? That is where it is helping us drive business decisions. That is where, automating so many things. I'm sure that all of you all have been ordering parcels from your favorite e-commerce sites, Walmart, be it Amazon, be it Flipkart or whatever it is, right? So when you're ordering it from there, just one product of yours traveling thousands of kilometers, it cannot be a very inefficient process. So every time one person orders something, and of course millions of people order on a daily basis, they have to find the most efficient way to get the product to you at the earliest, right? So that is where you'll be reducing logistics costs, you'll be reducing production costs as well. And once you figure out that there is so much patterns that are present, you will also understand, with the power of data science, we can understand the trends that are present, and certain hidden patterns, if you exploit, it will work really well for your business, right? So that's great. We understood what data science is. We understood why the world is going mad over data science. But one important thing is, why should we consider a concept of statistics for a domain such as data science? If we are dealing with a large amount of data, and if we are trying to take a look at understanding how we can handle the data, why are we bringing in mathematics? Why are we bringing in statistics? Well, let me tell you one very important thing. You might have heard of machine learning, of course. How a machine learning algorithm works is fascinating, because at the end of the day, how it analyzes data, how it sees data, and how your machine learning model figures out data is governed by a lot of mathematical entities. It's governed by a lot of concepts of statistics, right? So for us, looking at statistical formulas or looking at statistical concepts might seem a little complex at start, but if you take an approach of understanding where it is applied, why it is applied there, you will eventually backtrack and figure out how it works. This is one very important thing a lot of people try to miss. Whenever you're studying statistics, it's very easy to lose a track of the complexity it might bring. But at the end of the day, if you're a person who says, hey, I want to be a guy who wants to know statistics in and out for data science, use that approach. There's a very big difference between mathematics and applied mathematics, right? In data science, no one is going to ask you, hey, how does that theorem work? But people will ask you, which theorem do I use to solve this concept? Right, that skill is very much important. And statistics in general, whenever you're handling a large amount of data, if you require structure, if you require understanding, and if you want to just say, hey, tomorrow the weather is cloudy, are you sure? Are you just guessing? I can say that tomorrow it's going to be sunny here in Bengaluru, India, and it could be raining for days together, right? So that's just a guess. But when I say, hey, I know for a fact that 90% probability that there is rain tomorrow here in Bengaluru, and I have the data to prove it, it's no longer a guess. You are trying to establish a concrete reason to say that I can predict the future. Here is the data to support my claim. If you can do that, think about the possibilities in data science, right? This is again another reason why statistics is considered to be such an important part of the entire world of data science. Now Prasad asks a question, is this recorded and available to view later? Yes, Prasad, as soon as this live session ends, the video will remain on the Great Learning YouTube channel. You can check it out anytime that you want. So Probit says data application versus data science. Probit, what do you mean by data application? Let me know so that I can help you out better, right? Emeka says, please make a step on how to load your data from your spreadsheet on NumPy using Jupyter Notebook environment. Well, Emeka, that's a very good question. Just make sure to stick till the end of the video, because at the last, I'm going to be taking up a Python demo where we'll be doing exactly what it is that you are saying, right? I'm going to make sure that I'm going to guide you right from, finding a data set, picking up the data set, and eventually helping you understand the statistic that goes into it and understand how it is that you can solve a problem using statistics and data science. And I'm going to show you all of that practically as well. Now guys, coming to the process of machine learning, coming to the process of data science really quickly, you have to understand that machine learning, the concepts of data analysis, the concepts of data pre-processing are what makes the entire process of data science. For example, how do you begin to solve a problem in the world of data science? Let's attack this question. The first thing is, whenever someone comes to you with a problem, you try to understand the problem. You try to say, hey, this is the problem. Now I have a way I want to, try to solve this problem, and you're going to hunt for solutions. Once you find a solution, you're going to be like, hey, now I know the solution. What do I want next? What I want next is data to help understand the situation better, to help understand the problems better, right? So once you understand the process, saying, hey, I know what I want to solve, I have the data to prove it. The next thing, as I told you, is that data is a raw entity. You cannot expect your data to perform. Think about it. Whenever you're in the kitchen, you cannot eat all the food, all the recipes raw. There are some things which you have to process, and whenever I say this about data, you have to process it all the time, right? So once you have the data, once you begin processing it, later, even before you actually use the concepts of statistics and machine learning, you can actually use statistics to your favor in the process of data analysis. Now, exploratory data analysis basically talks about how you can perform analysis on data. The answer lies in the name itself. It says exploratory data analysis. You're trying to explore and hunt for hidden patterns that are present in the data, which you could have not done if you just looked at it with your naked eye, right? So this process of digging deeper, this process of hunting for treasure is very important. That is where statistics is involved. And from there all the way, look at this. The next step is, of course, machine learning. Every machine learning algorithm out there uses a concept of mathematics, uses a concept of statistics to work, because you as a person, whenever you've trained, you can look at the heading, you can look at the subheading, you can look at my entire presentation right now and figure out each and every thing here. But at the end of the day, if you try to get this to be understandable by your computer, it is a very difficult task, right? It doesn't know unless it is trained to see those things. That's where it's very important. And of course, after machine learning, ladies and gentlemen, the next step is to make sure you use the results in an understandable fashion. Again, if you are a person who knows data visualization, or if you're a person who knows that, hey, graphs can have a lot more impact than maybe an Excel workbook with like thousands of rows and columns of data, you will know the value of how important it is to take a bunch of data, convert it into a very easy to read, easy to understand manner, such that everyone, right, maybe a non-technical person like your client, maybe a person who might be a manager, maybe someone who came to you with the problem statement, understands it. Statistics is involved there as well, right? So little bit in each and every step, statistics is there, and without which it becomes very difficult for you guys to get started with data science, right? So with that, once we figure out that at this moment of time, I am sure that all of you all are clear with this fact that statistics is required for data science. It's critical, in fact. So the next question I usually get asked whenever we're discussing data science is, hey, now I know statistics, I want to learn statistics, but what can you tell me a little bit about programming? How much of programming is required? The advantage, ladies and gentlemen, in the domain of data science is for the fact that you have access to so many different programming languages, right? Right from the world of SQL, structured query language, through which you'll be working with databases, all the way to Informatica, Python, Java, R programming language, SAS, MATLAB, and a lot more. So if you just Google data science programming languages, you'll be given with a huge list. Again, it can get super confusing if you guys are freshers or if you guys are beginners who have never used data science, right? So my suggestion to you at this moment of time, when you're starting to learn statistics as well, put across a certain time to figure out how you can use statistics practically, as in through a programming language. And I would highly suggest you guys start with the Python programming language, because again, Python and statistics are like a match made in heaven, right? Superb. Now let me quickly pick up one or two of your questions. Naveen says, which concepts in statistics are required for data scientists? Well, Naveen, I'm going to be explaining all of these concepts which are super important. So welcome to the session. We're going to be discussing all of that. Hasso says, sir, what is the technologies or languages we need to understand data science and work in the field of AI? Well, that's a very good question. Regarding the languages that you're supposed to learn, you can pick up a couple right from your screen right now. So it is not a compulsion to say you need to know all of these languages or you cannot become a data scientist. Absolutely not. If you are very good with Python and if you're very good with Python's libraries, then definitely you know how to implement logic. All you have to think about is data handling, and SQL is an absolutely beautiful language to go about doing that, right? Now, we understood a lot about statistics, we understood a lot about where statistics fits in the world of data science, but diving right into the heart of the concept itself, but understanding the types of statistical analysis is very important for all of you all. Now, when we just say data analytics or when we just say statistics, you might not be able to connect all the dots. That's because there's variety, there's so many types of statistical analysis that you can actually perform that at the end of the day, if you do not know which one to pick, it can get very difficult, right? Now, to make sure that we can bring about the world of statistical analysis into an easily understandable manner, we can discuss two of the most important types of analysis that is out there. One is descriptive statistics, the other one is inferential statistics. Now, ladies and gentlemen, let's take a look at descriptive statistics. What does the name say? Descriptive. You're trying to describe something, right? Whenever you're trying to describe something, basically you're just saying, hey, I have the data and I just want to describe it more. Let me tell you this. So you guys tell me, what is your favorite sport to play, right? In India, it's very common that a lot of the male population love to play cricket and a lot of the female population maybe love playing hockey or any other fantastic sport that is out there. Right now, let's consider the hypothetical situation. So when you have to say, hey, when you ask a question saying, hey, so in this particular country, which is the most played sport, or which gender plays what sport? When you have to answer a question like that, you realize that you're going to have to divide the data between these two genders, or you have to analyze it, you have to plot a graph for it and eventually come to the answer to it. The process that you're doing, you're trying to describe what it is. You're trying to describe your solution through the concept of mathematics to provide to provide a very simple analysis out there, right? So that is descriptive statistics. There's another type of statistics, it's called as inferential statistics. Now, ladies and gentlemen, inferential statistics is basically you deriving an inference, you're making an inference based on what data you have at hand. Again, you have come across this in the real life as well. So there is a very good chance that whenever you've been shopping on Amazon or any of those sites, you might have just added a new mobile to your shopping cart, you might have just added something else. Do you realize that as soon as you add it to the cart, Amazon also recommends other items which other people have bought as well, right? So if you buy a book, Amazon will say, hey, there are other people who have bought pens, who have bought books as well, so do you want to buy a pen? Makes sense. Now, if you're buying a new mobile phone, Amazon will also tell you, hey, there are people who have bought new screen protectors, there are people who have bought new cases for the phone. Do you want to buy it, right? So that is an inference. Amazon knows it, right? That if people have bought this, they might be very interested in the other thing as well. Now, it will not give you random recommendations. It will never tell you, hey, if you're buying a pen, please buy this mobile phone as well, right? That would absolutely make no sense whatsoever. So again, how that is done is also involved in the world of statistical analysis. So describing the problem versus deriving an inference, making an inference and saying this is happening because of that, answering the question why, that is inferential statistics and descriptive statistics, ladies and gentlemen. Right? Now, Prashant asks a question, which course to do between artificial intelligence or data science, and which has the upper hand? That's a very good question, Prashant. Now, whenever you're taking a look at AI or data science, there's one important thing you have to understand is that AI is still inside the domain of data science itself. See, data science consists of machine learning and deep learning. If you remove machine learning and deep learning from the equation, you can never have artificial intelligence in today's world, right? So data science and AI goes hand in hand. To tell you, hey, pick up this one particular course. If you stay till the end of the video, Prashant, I'm going to be guiding you guys on how you can work towards specialization in the concept of data science. And as Prashant said, maybe you guys are looking forward to becoming a specialist in artificial intelligence as well. So I'm going to be guiding you on step-by-step manner of how you guys can go on to do that, right? Poonam has a very good question. Can freshers or beginners learn data science? Well, Poonam, welcome to the session. And my answer to your question is absolutely yes. A big yes written in capital letters. Because let me tell you this, regardless of what past experiences or what past education you bring to the table, at the end of the day, everyone has the capability to actually start from scratch, and with structured and very easy to understand learning, definitely freshers can go on to do it. As I told you, some people might say things like, hey, I might not be very good in mathematics, I might not be very good in programming, I might I don't like programming, I don't like maths. I understand the fact, maybe you just need a different look, maybe you just need a different methodology of how you should learn those concepts. Now, ladies and gentlemen, I'm going to promise you one thing. When we are actually checking out these statistical concepts, we'll be checking out measures, right? Especially the section where we'll be checking out measures of accuracy. It is very difficult to understand that concept without having to teach it in a very interesting manner. So I'm sure you guys will understand that, even for people who might not like programming, even for the people who might not like mathematics, if you just take a different approach, there's a very good chance you can fall in love with these concepts, right? Superb. So coming to the formal definition of what statistics actually is, it's basically us trying to apply mathematics, and it is us trying to understand how we can collect data in a structured manner and how we can actually analyze them in a good way, right? So everything, right, we've already discussed this, everything from us picking up the data from one place all the way to us saying, hey, here is the result of our analysis. Data science and statistics go hand in hand and fit everywhere, right? So as always, if you have to answer a question saying, let's just say there's a client who comes to you with a problem saying, hey, I've sold 100 mobile phones last month, but this month I only sold 20. where did I go wrong? Again, you see that at the end of the day, you have some metrics, you have some numbers that you can use to, again, perform a lot of analysis, to perform things like pattern matching, a lot of synchronization. You can do a lot of things with numbers, with mathematics, and once you start applying statistics, that is when, I want to say magic happens, right? So to understand how the world of statistics works, you have to first of all understand how it is that we actually go on to handle the data. Now, you might have heard of things such as population, a term such as sample space, and there's a very good chance you might not know what it is, right? So let's just say that we want to perform statistical analysis on certain concept that we have, a certain problem that we have. Once you realize that you have a problem, and once you realize that you have to start solving it, now if it cannot be practical for you to pick up whatever sales Amazon has done in one entire day around the world to sit and analyze it manually. They would have sold millions of products across the world every single day, right? So sometimes you have to break larger problems into smaller chunks through which you can understand. Now, this entire thing that we call our population is basically all the observations that we are trying to study. Now, in our demo, we're going to be discussing this practically. Let's just say that you are a person who's just trying to understand what causes the disease diabetes, right? And if you want to understand the symptoms of what causes it, you'll realize that it's not just one symptom. In fact, there are many more symptoms, right? So when you look at a whole data set, you will get more clarity about what it is. And if you want to say, hey, I see 20 people have diabetes, 30 people don't have diabetes, and then what will you do? Then you will say, okay, let me get a closer look. Let me try to dig deep. Let me try to look further. When you go on to do that, you're basically taking 100 patients worth of data and analyzing and focusing on 2-3 patients or 20 patients. That is when you call that as a sample space. A sample space is nothing but a part of a bigger chunk that we call as population, right? Now you might say, hey, the same data set example, the same diabetes example, probably if I have 1000 rows worth of information, that is the entire population. Now how do I sample it? Sampling it involves many ways. You can actually randomly start picking up the data, or you can, in an orderly fashion, you can start picking it up as well. Look at the image on your right side right now. Here you can see that target population consists of all the people that we'll probably be discussing, but a sample discusses only some of the people who are involved. I can pick up 1 out of 100. I can pick up 99 out of 100. That will still be a sample, right? It is considered as a portion of the entire thing. Now, we do this a lot because it's a super efficient way of how we can solve problems. Instead of just bringing in the entire data that we have probably of your client or the entire world to solve, we just take a small part of it, analyze it, probably take another small part, analyze. So we're going to be doing this in an iterative manner. That way you're covering more ground in a more efficient way, and you'll never leave a stone unturned, right? That's why we break things down in a simple manner, and that's how we understand as humans as well, and that's how our computers understand it too. Now quickly, let's consider what parameters are. Now when you say parameters basically are some of these things that we use to describe the population, right? So when I say, hey, there are 100 patients, how many of them have diabetes? Or when I say, what is the average number of people who have diabetes on the entire population, you realize that that's a mathematical operation you have to perform there. It's an operation that is describing all the patient data that you might have. It's an operation that says to find the average, there is a mathematical equation that gets involved there, right? And you might not be considering the entire population. You might just be considering 20 or 30 of the entire population, and you could still do it. If you want to do it for the population, well and good, you can do it for the entire thing. If you can do it for the entire thing, there's a very good chance you can do it for a smaller chunk as well, right? So ladies and gentlemen, that is what parameters are. And you might have heard of these two very important terms, mean and standard deviation. So these, the concept of mean is nothing but the average. The concept of standard deviation talks about how much each and every data point varies from the overall average. And once you have these two metrics at hand, you can do a lot of things, right? And On this lines, if you're talking about the measures of a central tendency, have you guys heard of this term mean? Have you guys heard of this term median? Have you guys heard of this term mode? Because this is very important. Even though it's a very simple concept in the world of statistics, understanding this thoroughly is super important. Mean basically talks about the average value of the population. Now if I say, hey, there are 10 people who are earning so and so salaries, how do you find the average salary of these 10 people? You just add all of those salaries divided by 10, you have the average salary of 10 people, correct? It's a very simple operation. What about median? Median is one of these concepts where you would try to find the middle value in a sorted population. Now if I just tell you, hey, if I just give you 10 different chocolate bars of 10 different sizes, and if I just say pick the one which is not too big or pick the one which is not too small. Now if it is put in a random fashion, you cannot just go to the middle point and say this is the one. Why? Because there's a very good chance it is not even ordered. It will not make sense. For median, whenever you have to find the middle element of something, you need to have an ordered. Now if you were to arrange those chocolate bars from its smallest to its largest, then if you go to the middle one, you can be assured of the fact that the size of it is not too much as well or not too little as well. You guys agree? Well, that is median, and it is very important to understand it will only work in a sorted population, right? Now, when we take a look at mode, understanding the mode is very important, because when we use the word mode in real life, it is very different to how we actually go on to do it in central tendency. In central tendency, it is the most occurring element in your data set. Let me give you an example. If I tell you, hey guys, here is here is 3 oranges, here is 4 apples, and here is 10 bananas. Now if I ask you a question saying which is the most element, which is the element that is present the maximum number of times, it's 10 bananas, right? So that becomes the mode of your entire problem. So whenever you have to discuss mean, it's the average. Whenever you have to discuss median, arrange everything, find the middle one. Whenever we are discussing mode, find the most repeated data element. It can be any data element. If it is repeated the maximum number of times, that is the mode, right? Superb. That is measures of central tendency. What about measures of something called as spread? Spread talks about how widely your data is, how wide your data is basically represented when you put it on a scale. As I told you, you can be a person who's selling mobile phones. Last month you sold 100 mobile phones, maybe in one day. Today you have sold only 20 in an entire week or an entire month. So once you understand, hey, how can I find out why things have been unusual for a while? Whenever you want to spot something that says, hey, I want to understand what is wrong here or why this is happening, this is where you consider something called as an outlier. Outliers are values which can be considered unusual. Now if I say, hey guys, there is a sheet that you guys have to fill, maybe you'll have to put in your details such as blood group and mobile number and all of that. Now imagine the fact that someone would have definitely can type it wrong. It happens. Or maybe when someone asks you saying, hey, what's your age, right? You could have basically, instead of writing maybe 30 or 35, you could have just added a 0 at the end. Of course you cannot be 350 years old in human ages, right? So it can be a mistake. 99% of the time, whenever there is something called as an outlier, or whenever a data element is misbehaving and it is out of range, that is when we say it can be an outlier, and it can be due to some human mistakes, experimental mistakes, computation mistakes, and all of that. One thing you have to understand is that why do we require measure of spread? Because if you do not understand measure of spread, it has a direct it has a direct impact on the world of understanding mean, on standard deviation as well. So when you say, hey, I just want to work on mean and standard deviation, but you never understand why your standard deviation is high, or you never understand why you're arriving at that particular mean value, you'll have to look at outliers, right? So it's an entire life cycle that you have to understand here. Now, the concept of spread also comes to a point where we'll break down data into very simple bits of chunks. Here as well, let's just say we have 100 rows of data right now, and if I say, hey guys, divide it into 4 parts, basically each of that is a quartile, right? Just how we do in our for our calendar as well. First quartile, second quartile, third quarter, fourth quarter, and all of that. Now, here when you break data into the maybe 0 to 25th percentile, we call it as quartile 1 or Q1. Whenever we just take everything that lies between 25 and 50th percentile, we call it as second quartile. Whenever we do it from 50 to 75th percentile, that is the third quartile. And whenever we do it from 75th to 100, as you guys already know, it's the fourth quartile. Now, ladies and gentlemen, one important thing that you have to understand is why do we even need to break things down into quarters? Again, think of the concept of population, think of the concept of why we have to make use of sample spaces, and how breaking things down can help you go on to arrive at a simpler solution, right? So that is very much required here. Now, of course, interquartile range is a metric that you can track in the world of statistics, and once you find out your value of Q3, once you find out your value of Q1, all you do is you do a simple operation. Q3 minus Q1 will basically tell you how much your data has spread. What is the interquartile range, as in what is your range of data for every quarter that is present? That is nothing but the interquartile range. Now, ladies and gentlemen, there are so many concepts that will govern the world of statistics. You don't have to be an expert at knowing what all of these are, but you have to be an expert of understanding how best you can implement all of these concepts, right? Now, let me just quickly pick up one or two of your questions. And I told you that I'm going to be giving you a wonderful explanation of how you can understand measures of accuracy. Right on your screen, you can see something called true positive, false positive, true negative, and false negative. For a person who is uninitiated, for a person who has never worked on data science, if you just look at these, you might have no clue what it is that we're talking about. And maybe if you read the definitions, you can get little clarity. But let me tell you that I can help you understand it in a complete fashion, right? Now let me pick up one or two of your questions. Naveen says, tell me something about Tableau, sir. Well, Naveen, Tableau is considered to be one of the world's leading Power BI, business intelligence tools. It's a direct competitor to Microsoft's Power BI. There's so many other tools such as ClickView, ClickSense, and all of that. If you're looking at a situation where data analysis and data visualization, creating reports and dashboards are very important, you should definitely consider. I mean, you would be good with either of these tools because the development goes hand in hand. If Tableau does something really well, the developers at Power BI will make sure Power BI can do it that well as well, right? So I hope that answers your question. Badal says, sir, please suggest me for data analysis courses. Well, Badal, as I told you guys, in another 10 to 15 minutes time, I'm going to be discussing the most structured way that you guys can work on, becoming specialists in the world of data analysis, data science, and a lot more as well. So make sure you stick around for that, Badal. Monica says, which course in Great Learning Academy is best for data science? Well, for all the people who do not know, Great Learning Academy is a place where we do provide free courses that will help you gain foundational knowledge on multiple concepts that are out there. Now, Monica, to answer your question, in our Great Learning Academy page, there's something called as career path. If you select the data science career path, it will show you in order of how and which certification courses that you can go on to do, right? Again, all these courses that you see on Great Learning Academy are free, guys. At the end of it, you will have a free certificate of completion as well, right? Superb. Deepak says, what is the main topics or content I learned for data science career? Well, Deepak, again, as we told you, right, the concepts of programming, the concepts of statistics, the concepts of data handling, and even the world of machine learning and deep learning is exactly what you are going to require here, right? Prasad says, what is the industry's best practices to choosing a sample? Very good question, Prasad. So there are two ways of how you can select a sample. One is via clustering and one is via random sampling. In random sampling, what you do is I say, hey, there's 100 rows of data. I'll say, hey, randomly give me 10 rows. That is still a sample. There's another way to do it now. You don't have to randomly pick it. There's something called as clustering. Clustering is basically you trying to divide it into further divisions and eventually picking it it up. Now if I give you a crate full of 5 oranges and 10 bananas and I shake it up, it's all random, it's all mixed. Now if I say separate the oranges from the bananas, you can categorize it. You can take all the oranges, put it on the left side, take all the bananas, put it on the right side. What are you doing there? It's again categorization, right? You can pick up 3 oranges, you can pick up 2 bananas from that particular list that you would have made an arrangement, and this kind of a categorization is a very good industry practice that we have out there. Emeka has a very good question. How to determine or measure the efficiency and accuracy of the results when analyzing data? Any special tools or techniques? Well, Emeka, very good question, because that is exactly what we'll be discussing right now. How do you know? How can you measure accuracy in the world of data science? What do we have that will tell us our machine learning model is accurate? What do we have that says, hey, this is not working as it's supposed to, or how well is this working, right? Very good question. That is exactly what we'll be discussing right now. Alright guys, I'm going to be picking up more of your questions. Let's quickly discuss this concept called as measures of accuracy. Now, if I just tell you, hey guys, this is true positive, hey guys, this is false positive, this is true negative or false negative, it can get super confusing even for a person who has worked in this for a really long time. So let me tell you a story to help you understand. First of all, let's just go back to the time when dinosaurs were roaming the earth, right? So in my opinion, I absolutely love dinosaurs. I watched Jurassic Park, the movie, maybe a million times. I just thought this example would be very nice to explain the situation for you guys. So back when dinosaurs were still roaming around the earth, let's just say that there was a T-Rex. We all know that the T-Rex is a carnivore. In the movies at least, it loves munching on humans, right? So let's just say that there is a village and there's a farmer who's probably doing a little bit of farming, and there is a situation where he actually spots a dinosaur coming his way. Now he has two options. He can run away, or he can go back to his village and say, hey, there's a dinosaur coming, so let's all get to safety. He has the chance to save his entire village, right? The farmer, it can be a he or a she. Now, one important thing you have to understand here, how we can understand the measures of accuracy, is via a simple story. Let's consider 4 situations that can possibly happen right now. 1. There actually is a dinosaur, right? The farmer isn't lying. The farmer sees a dinosaur right in front of him, and he runs back to the village and he says, hey, there's a dinosaur, let's all run. And they all run, they are saved. So what is the result? The situation was that there is an actual dinosaur. The farmer was correct, and eventually the village was saved. Take a look at the right side, the top right box right now. There is another situation where in real life there is no dinosaur. Maybe the farmer just saw a couple of tree branches moving around, or maybe he saw something else which is not a dinosaur. Now he says, hey, I saw a dinosaur. Even though there wasn't one, maybe he was confused, and he goes to the village. He says, hey, there's a dinosaur coming, everyone pack up, let's run. In this particular case, what happens is that even though there was no dinosaur in real life, the farmer was wrong. The farmer eventually moved his entire village away from that particular situation, right? So this is inaccurate in real life, correct? The left one is accurate. There was a dinosaur, farmer says there is a dinosaur, everyone ran away, everyone is saved. Correct. The farmer is accurate. On the right side, there was no dinosaur. The farmer just said there was one and everyone ran away. It is inaccurate. Look at the bottom left one, right? So again, this is another situation which is incorrect. There is an actual dinosaur. The farmer says, oh, that's not a dinosaur, or maybe the dinosaur sneaked up on him and he couldn't see it or something. The farmer goes back to the village and says, hey, I didn't see any dinosaurs today. What does the dino do? It eventually comes to the village, destroys the village, and you know how it goes, right? In both of these top right and bottom left situations, the farmer is wrong, correct? The farmer is inaccurate. Look at the bottom right situation. There is no dinosaur in real life. The farmer says, hey, I didn't see a dinosaur. There wasn't any dinosaur. Is the farmer wrong? No, the farmer is correct because he never saw a dinosaur. It was actually never there. Right? Now, how do we understand the measures of accuracy using that? You remember those four values that I showed you? True positive, false positive, true negative, and false negative. Now that I have it mapped on your screen, you will understand that if you tell your machine learning algorithm to maybe understand what a cat looks like or understand what a dog looks like, even though a cat has four legs, your dog has four legs, cat has a tail, dog has a tail, and all of that, you have to understand one thing. There are certain situations where your machine learning model will accurately predict what a dog looks like, and there's a very good chance it will also predict it incorrectly. It will look at a picture of a cat, it realizes that there's a tail, it realizes there's four legs, maybe it's very furry or something, it says that hey, this is a dog. Incorrect. Just like the farmer situation, just like the dinosaur situation, right? Now let me give you one more real life example here quickly. Let's just say a person actually has COVID-19. The person is COVID-19 positive. The person goes to the hospital. The person gets tested. The doctor says, yes, you have COVID-19 symptoms. Please isolate. Your test came out to be positive. That is correct. That is accurate. Now, what if the person never actually had COVID? The person maybe had a common cold or a cough. The person went to the hospital. The sample, something went wrong with the sample, and it still says, yes, this person has COVID. Even though in real life, the person never had anything to do with COVID. Maybe it was a common cold. This is inaccurate. Do you guys agree? Now you understand how we can go on to trace the measures of accuracy, right? Similarly, in a situation where the person does not have any symptoms, just wants to get tested, goes to the hospital, gets tested, the report comes out to be negative. In real life, he doesn't have COVID. The doctor says you don't have COVID. It works. So whatever you see in green, true positive and true negative, are the situations we are after. These are the numbers we want to be high whenever we're taking a look at understanding statistics for data science, and we always want to avoid these incorrect situations, right? It can be life or death, be it dinosaurs or be it the COVID-19 virus. Ladies and gentlemen, it becomes very, very important. We have a way to track accuracy of be it a machine learning model or anything else, and this is exactly used for that purpose, right? So once you understand that there are four numbers that you can have, true positive, true negative, false positive, false negative, using those numbers you can actually calculate so many things. There's something called as sensitivity, there's something called as specificity, there's something called precision, something called predictive negative. Now it's okay if you do not know these formulas, or it is okay if you are a person who might not be looking at it to a good amount of depth as well, but knowing for a fact that with respect to sensitivity, you can tell how accurate your machine learning model is. With respect to specificity, you can tell where your machine learning model works really well, where it doesn't work well. With respect to precision, of course, it's a score that will give you an overall impression of all the correct cases that your model has assigned, right? So there's so many things that you can track, and now that you have understood all those cases, how things work, and all the numerical metrics that you can actually use it to track, I am sure you guys have a decent understanding of that, right? Now quickly coming to the concept of hypothesis testing. Hypothesis testing is absolutely beautiful, guys. It is basically us starting out to solve a problem by making an assumption. Let me quickly explain what null hypothesis is and what alternate hypothesis is. The perfect example to explain this to you guys is the planet Pluto. Correct? You all know that Pluto, there is a lot of confusion with respect to Pluto. There was a time when people said, yes, that is in our solar system, that is a planet. Later they said, oops, sorry, it is no longer a part of our solar system, it is no longer a planet. You realize that, right? So at the start, they assumed, they were used to the fact that, an accepted fact that Pluto was a planet. But I'm very sure there would have been someone else saying, hey, Pluto is not big enough to be called as a planet, so I don't want to assume that Pluto is a planet at all. That is the alternate hypothesis. Null hypothesis begins out with you making an assumption which is an actually accepted fact. Later, whenever you want to solve the problem, you also have to think about it in a different angle. That is when you look at alternative hypothesis and you say, hey, maybe my assumption could be wrong, maybe my assumption could be right. Correct? to track that part, where do we have a numerical metric that will tell us that, hey, was Pluto really a planet or was Pluto not a planet at all? There is something called p-value in statistics that will basically either tell that it will give you a numerical metric to show you of which hypothesis you should consider. Should you consider the null hypothesis? Should you consider the alternative hypothesis? A common practice in our world is if your p-value is less than 0.5, there's a very good chance you'll be considering null hypothesis, right? And if your p-value is over, basically it's a value that lies between 0 and 1, and if it has to do anything above 0.5, the common practice is to say, hey, let us reject the null hypothesis. Pluto is no longer a planet. Right? So that is basically the p-value, guys. Now, as I told you, let me quickly go on to guide you about how you can perform this kind of statistical analysis that we have been discussing for a while right now. Now, this is Google Colab, ladies and gentlemen. This is nothing but a Jupyter notebook that is hosted on the Google Cloud platform. I absolutely love working on Google Colab because I don't have to install Python. I don't have to install any library. Everything is pre-installed. I can do it on my mobile phone. I can do it on my smart TV as well, right? Okay, cool. Now, ladies and gentlemen, the point of this particular demo is to show you the power, to show you where statistics can be used. There's a very good chance that some of you who are watching this demo might have never worked with Python programming, or even if you have, you might have never worked with data science in Python programming, right? So just understand the flow of what we do and the flow of how we do it, because at the end it is very easy for all of you all tuning into this session to basically understand code, right? Simple. So, as I told you, in the data science life cycle, what is the first step that we do? We gather everything that we want to solve the data. Here in Python, there's multiple packages. NumPy is basically called numerical Python, which is used to solve numerical, which is basically helping us with numerical computations. We have a library called Pandas. Pandas helps us by giving us more data structures. Matplotlib and Seaborn are nothing but data visualization libraries. You will see why we require data visualization here. And sklearn is a very simple library. It's called as scikit-learn. Now guys, how many of you have heard of scikit-learn? Head to the comment section, type in a quick yes, because scikit-learn is very much important for the world of machine learning. Now as soon as I hit the play button, I have imported all the packages that is required for me, right? Now, one important thing you have to understand after importing all the libraries is, next thing is, hey, now our Python program is sort of getting ready. It knows where to pick up what concept from. So we require the data. Now, if I just hit play on this data, it's going to give me an error. Why? Because it doesn't understand where the data is. It doesn't know it. The data is on my computer, but this is on the Google Cloud. So let me quickly, import the diabetes data set. Right, you can see that it's showing diabetes data set. There was a circle showing progress, and it's done very quickly because it's a very simple data set. Now that I click on it once again, it runs very well. Why? Because it knows what the data set is. Now let me quickly show you guys what the data set is. Let me zoom in so that all of you all can see better. Now, ladies and gentlemen, if I ask you a question, or if you were to ask your doctor a question saying, hey doctor, what causes diabetes? You have to understand that there's many reasons of what might cause it, right? One important thing is the blood sugar level, the blood pressure level. It can be your age. It can be the insulin level in your blood. It can be something called as body mass index. Body mass index will tell you how much of a fat percentage you have. And we have seen a common pattern that if people tend to be obese and if people tend to be eating unhealthily, there's a very good chance they might have diabetes as well, right? So our data set looks something like this, where we are trying to get our machine learning model to actually predict and understand how, if it can predict if a person has diabetes or not. The logic is very simple. We have maybe somewhere around 700 or 800 patients' data. Each of this row that you see is one patient's data. For example, this person has a BMI of 33 and is of the age 50. There's a very good chance this person has has diabetes, because this BMI is very high. It's literally obese, as very much obese, right? So when I take a look at the age, when I take a look at the BMI, I can guess, hey, this person has diabetes. And look at the outcome. If the outcome says 1, it means this person has diabetes. This is not our machine learning model telling us. We already have data to know if the person has diabetes or not. Fantastic. Now, what's the point? What we are trying to do here is to basically remove this last column, just supply everything apart from the last column, basically give all the questions and all the data to your machine learning model, and eventually get your model to figure out and tell you if it can accurately predict the outcome correctly or not. How do you trace it? You trace it using the metrics of accuracy, true positive, true negative, all those we discussed, right? So we're going to take a look at that. But first, here are all the columns of data which can basically have an impact on the person maybe having diabetes or not. Maybe even the number of times a person has been pregnant also has a significant impact, is what I have heard, and it's what's seen in our data set as well. What is the glucose level in your blood? What is your blood pressure? Maybe someone who is super healthy, who eats very good food, who eats healthy food, maybe has a very high blood pressure problem. That person can also get diabetes, right? That's the entire point. We can understand it very easily. Getting our data set to understand it is very important. Now, the question that you guys might be having is, okay, so if we are just looking at this data, how many patients' data do we have to train and understand using statistics? Well, we have 768 patients worth of data, and for each of those patients, we have details such as pregnancies, glucose level, blood pressure, BMI, age, and eventually the final outcome that will tell us if this person has had diabetes or not. Alright, so Shivam says, I got a doubt. Can you please help? Of course, Shivam, put down your question. Let me see if I can help you out there. Probit says, student must raise their hands first, not the mentor. Well, Probit, I raise my hand now. Alright, cool. Let's just get back. Now, understanding statistics, ladies and gentlemen, one simple command, data.describe, basically it can be anything.describe, will tell you what, everything that we just understood. When I count, basically will tell you what is the count, what is the number of data points we have for each of these. Mean will tell you what is the average of it. For example, look at insulin level. The average insulin level is considered to be 79 for everyone. The average insulin level, the average body mass index for the entire 768 people is 31. So you should be thinking about something like, hey, if the average population's BMI is so high, can there be a chance that all the people can be diabetic? All of that you can answer just by looking at this. You can take a look at standard deviation, and you can understand how each of the data points will vary from the average in itself. And ladies and gentlemen, when you take a look at other things such as interquartile range that I just told you, right? Everything from minimum to 25th percentile is considered as Q1. Everything from 25 to 50 is considered Q2. Everything from 50 to 75 is Q3, and 75 to max is Q4. You remember I told you how you can break it down into quartiles to perform even in-depth look at your data? That is literally what Python did for you with literally the help of 10, ladies and gentlemen, 10 characters out there. That is how simple it is to work with Python. Fantastic. We know what the data is. Our data is imported. The next thing we need to do is check if we have any inconsistencies in our data. You remember when I told you data is a raw entity? Well, what we're going to be doing here is to understand if we have any sort of values which might not make sense. For example, if someone says, what is your age? You can have a number between 0 and maybe 100 or something, right? Now, if someone has incorrectly entered 1,000 instead of 100, it won't make sense. So what we will be trying to understand is to find out if there's any errors like that. For example, if someone asks you your BMI, it is a number. Maybe the person just thought it might be the blood group. The person just typed in O positive. Doesn't make sense, correct? So thankfully in our data set, all of that is clean. All of that is good enough. So it works really well. You might have a question, you might be a person to say, hey, so if we are trying to understand how many people have diabetes, how many people not have diabetes, can you help us out? Let me tell you this, out of these 768 people, 500 people have diabetes, while if 500 people have diabetes, it means what? The remaining 268 do not have diabetes, correct? So this is where data visualization comes into the picture, ladies and gentlemen. If you look at this, just by plotting, let me zoom out a little. Just by plotting one graph again with 2 lines of code, you cannot look at anything else and just look at this, and can't you guess how many people have diabetes, how many people have not have diabetes? You can do all of this just by doing 2 lines of code. And that again is why all the people who are asking question in the comment section saying why is data visualization important, or can you explain something like Tableau or Power BI, you can do this to an even more in-depth level, and that is what is important. Shivam says how to build a visualization using one variable in R. Well, Shivam, what is the exact problem that you are trying to solve? If you're trying to build a visualization using one variable, what are you comparing it to? If you have apples and if you have oranges, you will have something to compare it to, right? So if I just give you an apple and if I say compare it with what, right? So what are you trying to compare it with? If you let me know that, I can help you out. Right, so next step is very simple, ladies and gentlemen. All we are trying to do is we are splitting the data and sending some for training and sending some for testing. This is a very simple concept that you would have used in your real life as well, just like your examination in your college and all that. Now comes the fun part. When someone asks me something related to machine learning, they say, Anirudh, do we have to write hundreds of lines of code for machine learning? Guess what? The actual process of where the training happens, the actual process of where your machine learns, right, where all the statistics concepts go on steroids, right? This is just one line of code that will help you do that. Now as soon as I click the mouse on this button, it's just giving me a warning saying it has trained multiple times. Well enough, it has learnt everything it has to do. The next thing is to actually test if it has performed any sort of predictions correctly or not. You remember when we spoke about metrics of accuracy? When there was a dinosaur, the farmer had to say there was a dinosaur. The farmer, if he told wrong, people would, the dinosaur would destroy the village. Similarly here, when I print something called as a confusion matrix, ladies and gentlemen, you remember those 4 values we took a look at? True positive, true negative, false positive, false negative. You remember when I told you you are very much concerned about having these values to be very high while these two to be very low? Top left, bottom right, high values, top right, bottom left to be low values, right? Now this is where this one matrix will tell you in how many cases your machine learning model went wrong, where the person could have had diabetes, your machine learning model thinks the person does not have diabetes, or the person in real life does not have diabetes, yet your machine learning model could say this person has diabetes. So these are those 2 cases, but the other 2 cases are there. The person actually has diabetes, the machine learning model told, hey, I can predict this person has diabetes. Now there can be one more case where it says, hey, this person does not have diabetes. As a machine learning model, even I think this person does not have diabetes. It is correct, right? So that coming to this point of where we can analyze the accuracy to a very in-depth level, you realize we have to do so much in data science, right? So it's always important that you guys have a complete understanding. That's why we started out the session right from the basics of data science, right? Now, the next thing is very common. Basically, when you ask a question saying, okay, so how accurate is your machine learning model? Tell me a number. I can tell you that for every 100 patients worth of data, my machine learning model will work very well and it will predict it with 100% accuracy for 75 patients. Correct. So maybe, maybe at the end of the day, if you're trying to achieve 100% accuracy, you will have to train it differently. You have to maybe bring in a lot more data. But since we're discussing about statistics, what we should be considered is things such as this, things such as precision, things such as recall. You remember when we spoke about precision and recall, when I told you that this is a metric that you can have access to, right? So basically, whatever you see here, 0, this discusses about how accurate your machine learning model was to, to figure out when people never had diabetes. 1 talks about the actual situation where your people had diabetes and eventually, how well was your machine learning model figuring out when people actually had it, right? Sai Naidu says, can you please share the data set and the code? Of course, Sai Naidu, this is a very popular data set which is available for free on the internet itself. So you can definitely, go on to pick it up from anywhere. Of course, we are going to, give you the notebook as well, so you guys can go on to work with it. Shivam says, I am working on the Titanic dataset which has zeros and ones for people who have survived, so I have to make a visualization on the basis of that. Well, Shivam, this a very good question. Just like as I showed you here, right? So whenever you are trying to find, if the person survived or not, survivability will become one metric that you can track, as in overall count of your people. So it's never one variable that you're doing. Your outcome might be 0, as in the person didn't survive. The outcome can be 1, the person actually survived. But to count it, to have a measure, you will count it against everyone else. You will take 100 people, and eventually out of those 100 people you can say who survived or who didn't in your case, right? It's very simple. Sam says, hey sir, it's cool. Yes, Sam, the entire world of data science, the entire world of statistics is definitely very cool in my perspective. Now, ladies and gentlemen, I usually get asked the question at the end of the session, saying, yes, all of these we have learned, all the concepts we have learned is actually clear, it's very good for our foundation. Where can we go ahead to learn more? Well, there's multiple places here at the Great Learning ecosystem wherein you can definitely learn for, you can get started to learn these fundamental concepts all for free, ladies and gentlemen. First of all, we have our Great Learning YouTube channel, which again, you guys, I absolutely love teaching all of you all on the Great Learning channel, and you guys, keep it always interactive, right? So you can find not just data science, not just my videos, but there are a lot of subject matter experts here who are creating a lot of content for you guys. So do take a second to support the channel, hit that subscribe button, and at the end of it, more than you supporting the channel, at the end of the day, you will be the first ones to have access to the highest quality learning material that we can put out, right? So it's a win-win just for you guys. Again, superb. After this, you have Great Learning Academy. Great Learning Academy is a place where again you can have access to multiple courses, hundreds of courses. You can complete those courses for free and eventually get a free certificate of completion as well. Kiran Kumar says, very nice explanation. Well, Kiran Kumar, I am glad you enjoyed it. I hope it really, I hope it really helped answer some of your questions. I do see that you have asked one question previously as well, Kiran. You said, please inform about switching my career to data science. I know a lot of you guys have this particular question wherein you might be coming in from a variety of background. You might be coming from a lot of different backgrounds, and you might have a question saying, hey, how can I build a successful career in data science and business analytics? Well, let me tell you this. When you think about understanding how to approach a really big domain such as data science, be it you are a fresher, be it you may be a digital marketing expert, a thorough expert, but moving to data science, you're gonna have to train from scratch. Now, we have multiple post-graduation programs here at Great Learning, which will give you top-tier access to make sure you guys can become specialists. Our goal with these post-graduation programs is to make sure we take you from you being a beginner all the way to you becoming a specialist, you becoming a thorough expert there. So ladies and gentlemen, I present to you one of these programs, one out of many programs that we have, wherein you have to understand that having a post-graduation program in this particular domain is very beautiful, right? So we have had over 8,000 plus career transitions with over 500 plus hiring partners that you get access to, and people say that they've had an average salary hike of over 48% after they switched from a completely different domain, from a different company, all the way to coming towards data science, right? So the advantage of you guys taking a look at a program here at Great Learning is for a fact that this course has been designed for professionals. This course has been designed by professionals. Now we have more programs wherein, for example, the data science PG program in data science and engineering. Now this will get you started with the domain, because here we'll be starting right from the foundations of how you can do Python programming all the way to you actually understanding the world of data science, working on projects in it, and eventually working towards prepping for your career and all of that. Now, when we take a look at this particular program we're discussing right now, data science and business analytics course, this is a program that is done in collaboration, ladies and gentlemen, with the University of Texas at Austin. So whenever you complete these programs, you will basically have two certificates, one from the University of Texas at Austin itself and one from Great Lakes Executive Learning, right? Certificates are super important for all of our careers. We already know that, but what you should be understanding is the curriculum that we are providing is absolutely amazing, because the curriculum has been completely designed by experts from Great Lakes, by experts from the University of Texas at Austin, basically the McCombs School of Business. McCombs School of Business was ranked number 6 in the entire world for business analytics, right? So guys, right from the introduction to data science all the way to understanding what are the various techniques that are out there, understanding how you can use data science in multiple different domains. Now, some of you might be saying, hey, I want to become a data scientist, but still I want to be working in social media analytics. Maybe I want to still work in digital marketing, but now as a data scientist. Well, you have multiple options to pick from. You'll be working on multiple projects in each of these sub modules that we'll be discussing. As you can see, we have multiple modules. We will have one very big capstone project you'll be working on. In fact, you'll be working on multiple projects. This capstone project will be a project you'll be working under the guidance of our mentors. This is an industry level problem that you guys are trying to solve. We'll be giving you career assistance in the form of resume building, mock interviews, and giving you access to our hiring partners as well. You can take a look at the various projects that was completed, and as I told you, you will be learning from the top basically, in my opinion, the leading academicians in the field of data science and business analytics, right? So all of these guys are thorough experts in these domains, and they have been doing this for a really long time, and they have handled thousands of students. So ladies and gentlemen, learning from the best will definitely help you navigate around this complex domain of data science. And it's not just the faculty that will help you. You have mentors standing by who will ensure that you have if you want help at any point of time, be it live sessions, be it any of the doubt solving sessions or whatever it is, these mentors will ensure that they will help you get across and navigate the domain as well. We've had so many learner achievements. So many of our learners have gone on to publish papers in top conferences, journals, won multiple awards, and a lot more. Well, guys, the program that I just discussed with you is not a 15-day program, it's not a 20-day program, but it's a very comprehensively put together program which is of a duration of 11 months. Now, this is completely online. It gives you access to 225 plus hours of learning content. You get career support through interview workshops and more. You get access to 350 plus companies we are tied up with, and you also get individual doubt solving sessions. You get to work on 17 real world projects as well. Of course, guys, since this is a program that is meant to take you from you being a beginner all the way to you being an expert, and you're learning from the experts at Texas, the University of Texas and the Great Lakes Institute, you definitely will have to understand that there is a small fee that comes with it, right? But in my opinion, being in the field of data science all my life, I can tell you for sure, you are definitely getting a huge value for your money whenever you're considering something like this, right? Now, I just quickly walk through all of this in the last 2 or 3 minutes. If you click on this download brochure button, it will give you a thorough detail of what the entire program is. You can find out all you have to know about the application process, the next when is the next batch starting, when is the deadline, and all of that. And of course, guys, at the end of it, I understand that some of you all definitely require more help to understand which data science program to actually pick up. What is your career goal? How can us at Great Learning, how can the experts at Great Learning help you get towards that goal? Well, all you have to do, ladies and gentlemen, is just put down your name, put down your email, put down your mobile number, and put down your work experience. You can be a college student, you can have less experience, you can have less than 1 year, 1 to 2, 5, 10, 12, 20 years of experience. Just put it down there, hit submit. what happens when you hit submit is that we will make sure someone from our admissions office will actually give you a call to help you understand better. So any questions that you have regarding how you can get towards working on your specialization, especially in an extremely competitive like domain like data science, they will help you out for free. They will only give you a call in the next 4 hours. All you have to do is put down your details there, and you can be confident that with these programs, if you put in the work that is required, ladies and gentlemen, all of you all who are watching this particular live session, you guys can definitely become thorough experts, right? So there's multiple specialization programs, multiple post-graduation programs, and we are tied up with some of the most prestigious universities across the globe, like Texas, the University of Texas, Northwestern University, Stanford Business School, and a lot more as well. Right, guys, with that, we have come to the end of this particular course. We've come to the end of this live session. Ankit says, does Great Learning offer this course to undergraduates also? Yes, Ankit, even if you're an undergraduate, that would be your perfect time to get started with data science. As I told you, just put down your details there and hit submit. Let our experts give you a call for free, and they can actually go on to guide you about that. Right? Well, guys, with this, as always, I hope, ladies and gentlemen, head to the comment section and let me know if you are clear with all the points on the agenda. We started out right from the basics of data science, right from the basics of statistics, and in the last 1 hour 15 minutes we learned so many things. Right now I am sure you understand measures of accuracy. If you probably read a direct definition of it, it can get confusing, but use the dinosaur example, use the example of the COVID-19 prediction thing, and you will figure out, hey, so this is how my machine learning model will learn. This is how statistics is used in the world of data science, right? So it's just all about learning. If you find the most efficient way, if you find a very different way to learn, I can assure you that for the people here, you can love programming, you can love mathematics, and if you've been doing long enough, just like me, you guys can definitely fall in love with the entire domain of data science as is, right? Well, guys, thank you so much. Thank you so much for tuning in. Thank you so much for all of your comments. Thank you so much for all of your questions. You guys are absolute legends, and I'm sure with this you can go on to have a solid foundation for your career ahead. On that note, guys, have a beautiful evening ahead, and definitely this is the right time to work on your data science specialization. So make sure you're not missing out on the current trends. Right, guys, my name is Anirudh Rao. Thank you so much for tuning in. As always, I am excited to